Now let's see the types of classes. The classes can be things remembered or data processes, like the user information, event, course, and book. A class can also be organizational unit. It can be company, tutorial group. A class also can be structure like list and table. Now let's see the class diagram. The class diagrams represent the structure of the system. The class diagrams are used during the requirements analysis to model application domain concepts. Uh, the class diagram also can be used in system design to model subsystems. They also can be used in object design to specify the detailed behavior and attributes of classes. So, for example, this is a simple class diagram including two classes. There is an association between the two classes. So now let's look into the class. A class represents a concept. The class name is the only mental information. So a class encapsulates state and behavior, like this example. This is an class. It has the name, tariff schedule. It has attributes zone 2 price. It has two operations, get zones and get price. Each attribute has a type and each operation has a signature. So we specify the type before the attribute and the signature before the operation. We may wonder the difference between actor, class, and object. So actually for the actor, it's an entity outside the system to be modeled, interacting with the system, like passenger. For the example, in the enter secure facility use case, the fingerprint reader is also a kind of actor. So the class is an abstraction modeling an entity in the application or solution domain. So actually the class is a part of the system model, like user, ticket distributor, and server. The object is a specific instance of class. For example, if we consider passenger as a class, then a passenger who is purchasing a ticket from the ticket distributor is an object. The class does not exist in the system alone. It has a relationship with other classes. So we use association to denote the relationships between classes. So for this example, there is an association between tariff schedule and the trip log. So the multiplicity of an association end denotes how many objects the instance of a class can legitimately reference. So for this association, it can be explained as the instance of a tariff schedule class can reference many objects of triplet, and the instance of the triplet class can reference many objects of tariff schedule. So basically, the association between class can be one-to-one, like this one, country and city. Country instance can reference one city object, and one city instance can reference one country object. And the association can also be one-to-many. So like this one, the polygon instance can reference many point objects. The association can be many to many. So like this one, the stock exchange instance can reference many company objects, and the instance of company can reference many stock exchange objects. Now let's see some special cases of the association. First, for the aggregation. Aggregation is a special case of association denoting a consists of hierarchy. So like this example, the exhaust system, it can consist of exhaust and tailpipe, and we use the diamond to represent such kind of association. A solid diamond denotes composition. It's a strong form of aggregation where the lifetime of the component instances is controlled by the aggregate. So for this example, the ticket machine consists of zone button. We use the solid diamond to represent the composition, meaning that the zone button must rely on the ticket machine to exist in the system. To reduce the multiplicity of an association, we use the qualifier. Like this example, without qualification, the directory and the file has the association one-to-many, meaning that uh, uh, a directory object, a directory instance can reference many file objects. So to reduce the multiplicity, we add the qualifier in the directory. Then the multiplicity becomes this one, 1 to 0 to 1, meaning that there is at most one file with the specified file name. For another example, we can see that before the qualification, the multiplicity for the association between stock exchange and company is a many-to-many, and after qualification, we add the qualifier ticket symbol to the stock exchange, then the multiplicity becomes many-to-one, meaning that one company instance can have many ticket symbol objects, but one ticket symbol instance can only reference one company. Inheritance is another special case of an association denoting a kind of hierarchy. So inheritance simplifies the analysis model by introducing a taxonomy. Like example, we have the button class, and the button class can be a cancel button or a zone button. So we consider the button as a parent class, and the cancel button and the zone button as children classes. The children classes will inherit the attributes and the operations of the parent class. Okay, that's all. Thank you.